Hello all and welcome to my YouTube channel. So today in this particular video we're going to be training a custom NLP model for our question answering task. So before we move into details, let us understand what is this question answering task. The goal of the question answering is to find the answers to a given question for a given paragraph. So in this particular question answering task we will be given a context or a paragraph, and for those paragraphs we will given a certain questions and we'll be finding out the answer for those questions. So we're going to be training a particular model for this particular task, and we will having a particular data required by the particular format, and we'll pick that particular paragraph and pass it to the model with certain questions, and the model will be able to learn those patterns and answers with respect to that, and it will be able to pick the answers. So this is what we're going to be doing in this particular tutorial. So before we move further, let's understand the data format required for the model to be trained. So for that, we have to prepare the data in this format, which you can see in the screen. So you have the trained data, and in that particular trained data, it should be having the context, that is a particular paragraph. And for that particular paragraph or the context, we should be having a question and answers. So in this particular question and answer tag, we should be having the questions with respect to the paragraph and answers for it. So this is the question for this particular paragraph, and this is the answers for this question, and this is the starting index or the character number which is present in the particular paragraph. So this is the answer for this, and the character number from where this answer starts into the particular context is the 71th index. So this is what a particular data should consist of, and these are the nitty details which should be present inside this data. So this is an ID number which should be present, and it should be unique for every questions in whole of the data set, and this signifies this underscore impossible signifies that whether the data is able to answer the questions or not. That means it indicates whether question can be answered correctly from the context or not. So this is what is underscore impossible tells us about. So, and you can see this all needs to be prepared in a format of JSON. So this all details should be present in form of JSON. So once you have a data like a paragraph, questions and answers, so you have to prepare in this format. The data should be prepared in this format, and this is just for one paragraph, and then we can continue for next particular set of given of paragraphs. So this is the second paragraph, and for that particular set of context or paragraph we will be having question answers and respective IDs. So you can see these IDs are for different question it has unique IDs. So it has different ID, now this has different ID, and similarly the questions will be given with respect to this context, and the answers will be given from this context only. And we should be always mentioning like from where, like in context, from where the answer is starting. So the starting point is at 28th character, so it must be here. So this is what the particular data format looks like, and after that you have to prepare a JSON format. So this is particular JSON format which you are following, and this is the format generally the model takes in for training. So this was the training data set, and now we'll see the evaluation data set. So evaluation data set is almost similar to the training data set. So it has context, that is paragraph, and question answer, and similarly for this question answer we have this questions and IDs, unique IDs, and this is underscore impossible and answers for this particular questions. So this is the answer and the starting point of this answer from this particular context. And similarly you can have two answers for this particular question. So this is what also we can mention it, and similarly for other paragraphs. So this is how you prepare the data set for trained data and evaluation data. And now suppose we want to get the predictions for the new data set. So this is the new data set, that means the new data which will be coming into this when the model get trained. So for that new data set we shouldn't be having any answers to it, only the context that we will be passing into the model, and the question respective to that context. That's it, and with ID number that is a unique, and we will expecting the model to be trained. So once the model got trained in this particular data format of train and evaluation, we'll pass this data, a new data, which has only context and the question. So it will start creating the answers with respect to this context. So this is all about we want to be doing in this whole tutorial. So for this tutorial, I will be using a simple transformer library, and we're going to be installing it over here. So we'll just install this simple transformer library, and I have covered a lot of videos on this, and you can just check out my YouTube channel where I have mentioned an NLP playlist. So we have series of videos of different kind of NLP tasks. So I have prepared an NLP playlist over there, so you can just go and watch those videos to get a more understanding of other kind of NLP tasks such as NER, text generation, text classification, other kind of stuffs which are generally there in NLP. So those are all shown with the training of BERT model as an example. You can also change it with different kind of models. Okay, so I think it has installed this simple transform library, so we just have to restart the runtime. And once this runtime get initialized, so we'll see the data which we're going to be using it for our practical purpose. So for this particular tutorial, I'm going to be using this Stanford question answering dataset, which is a benchmark dataset which generally researchers take this dataset and test the model on there and check the performance of their model. So this is also a particular dataset which is generally used in research fields. So we are going to use this as our training data. So I am going to download this training dataset and test dataset from this particular site, and then I have uploaded it over here in the VM of Colab, and then from here I am loading it in the form of JSON. And let me open this dataset so that you can compare, and we have to arrange this particular dataset in our given format as I have explained about. So you can see the dataset has many things which are not required, which you can see there are many entities which are not required. So we have to remove these entities, and we have to get only this paragraph context from here, because the most of the things are here only. So we need context, questions and answers. This is our requirement for our preparation of the data format to get the question answering task trained. So this is the data format, and this is what we required from this particular data. So we will write a simple script to extract it and convert it into our given format, which I have explained it above. So this is the simple script. We just have to write it. This is the loading part of the dataset. So we are loading this JSON file, and once this file get loaded, we are just passing a script or a simple line of code to just get the things aligned in our data format. So we'll run this, and we'll see the first indices of this train data. And so you can see this is the output of the particular data format which we are required. So this data has been extracted from this particular data which has been downloaded from Stanford, and we have converted that particular data and extracted the related information for our training. So this is what we require: the context and question and answers. So this is a question, this is the answer, and we require the indices from where the answer is starting. So this is the details we require, and we have extracted from the data and prepare the similar way how the data set, how the data format is required for our training. Now we'll use the simple transformer library, and we'll use its dependencies and its features like question answering function. So we'll use this question answering model function from simple transformers, and we'll give its hyperparameters. So the hyperparameters looks like learning rate, number underscore train epochs, and sequence length. So this is the hyperparameters which we can give and to train our models. So this is what I am giving over here. You can play with it, and you can just even go to documentation and understand how the things works with hyperparameter tuning. And once you have set this hyperparameters according to your judgments, then you can just initiate this function question answering model, and you can provide the name of the model which you're going to be using it. So I am using BERT model. You can specify any other model as well. So for this tutorial, I'm going to be using this BERT model. So I will specify the BERT, the model name BERT, and the the pre-trained weights which I am going to be uses of BERT base and case model. So once you specify these two parameters, it will be start downloading the model of BERT, and you have specified this hyperparameters inside this argument parameter. So once you have mentioned these kind of things, it will load into the model and it will start downloading as soon as you run this cell. So let's wait and watch. So we can see that model has been downloaded. So all the pre-trained weights of this BERT based model has been downloaded and it has been saved into this model parameter. So once this model has downloaded, we can use the train underscore model methods, and inside this method we'll pass our training data. So as of now, I am not passing whole of the train data. I am just passing the first 50 samples of train data because of computational issues. So with that reason, I will passing only 50 samples from the first, and we're gonna be training only on the 50 samples. So let's run this and let's see the output, how this model gets trained. So remember, it will be trained for only 2 epochs because we have mentioned in the hyperparameters we'll train for the 2 epochs. And once this get trained, we'll see the output and results. So let's wait for it get to trained. So this model has been trained and it has been trained only on 2 epochs. So you can see it has ran first epoch and the loss was 2.8047, and epoch second it has 4.0029. So it has increased the loss. So that means we have less data and we have given the less epochs for train. So the performance may be quite low, but yeah, for this tutorial we have configured, like we can change the parameters and get the epochs more by changing the hyperparameters above here. So once this training is been done, we can see in our output results, output folder here, and you can find the train files over here, and you can just take these train files and use it for your inferences as well. So once this model has been trained, we can take our development set and we'll change the format of this development set to the given format, that is the required format. And once this required format is achieved, we'll evaluate our model. So let's run this code. So it is similar to the above code, like how we prepared for the training data. So it has prepared the similar way. And once this data is prepared, so we'll use the print method from model, and it will just use the train parameters and evaluate on the development set. So let's run this code. So you can see the predictions has been done. So now let's print out the predictions. What are the predictions that it has printed? So let me scroll up little. So you can see it has printed the answers, only the answers for particular given questions. So let's see the development set. That means the first part of it, the first indices of the development sets. So you can see the development sets had the context and the questions and the answers for it. So you can see the answers wasn't given because we wanted to print the answers. So it has only the context and the questions for it. Similarly, we have different questions for this particular context only. So these are questions and answers for this particular given context, and these are the answers the model has printed. So if you see, it has printed West Francia. So the question was, in what country Normandy located? So it has said it has printed West Francia. So that means it is able to identify the country's name where the Normandy located. So if you even go into the context, you will be able to find the answers for it. So let me just search for you. Yeah, you can see West Francia. This is where the answer is. I hope it may not perform well for few of the dataset, but yeah, if we train for longer and change on the parameters, we can get this model trained and perform better. So once these predictions are done for this particular test data, what we can do is we can just save these results in a particular JSON format, and we can use these results and give it to the development team, and they can just develop a model over it, and this is what we can do. So let's run this cell and we'll save this whole result in a JSON format. Okay, so once this is done, we will refresh it out and we can see the results are printed here. So let me open this JSON file, and you can see that we have this particular question ID, and for that particular question ID we have answers for this. So this is how you're going to be doing it. So once you got the predictions, you can save the prediction results into the JSON folder. So this is how you are developing a question answering model by using BERT. You can also specify using different kind of models. You can prepare a GPT-2 model or any GPT-3 model or Excel BERT. So any kind of model you can use over here for training the question answering task. I hope you have enjoyed this video. So this is all about this particular question answering task. If you have any questions, comment down in below, and please subscribe my channel if you like the content. Thank you.